go to this page here, torontojs.com/code of conduct, and reach out to us through those means. In future slides, we'll see who are the volunteers, so you know how to spot them. Or slide. But I would like to thank our sponsor this year, starting with super.com. Super has been amazing, giving us space to host these meetups for, I think, more than 2 years now. I've hosted all the meetups that I have organized in Super. So that's how long it's been going on. We actually have Kyle from Super here over there. We'll get him around here to say some words and talk about Super and what they do and why Kyle is here today, thankfully.
Hey everyone, I'm Kyle. I'm an engineering director here at super.com. I'm here today because I worked from the office today and it's fun to be here. We're hiring. We've got a couple roles open for intermediate and senior full stack software engineers, a senior DevOps engineer, and a couple QA roles, both analyst and engineering. I'll be walking around. I got a Super Plus or super.com shirt on. So after this, if you want to say hi, let me know. You can find me. Thanks.
Great, thank you. That's a good segue for me to ask a quick couple of questions to understand you better. Do me a favor, based on what your answer is, raise your hands. This gives us an understanding of who you are so that we can understand what talks, what kind of topics we can present to you. So first of all, is this your first meetup? Raise your hand if this is your first meetup. All right, great. And is this your repeat meetup? Raise your hands if this is your repeat meetup. A second one. Okay, 50-50, good to know. Experience-wise, raise your hands if your experience is less than 2 years. All right, raise your hands now if your experience is 2 to 5 years, experience range. All right, and if you're more than 5 years experience, please raise your hands. All right, good to see senior folks. That's a good segue again to jobs. Raise your hands if you would say you're in the job seeker category right now. All right, and now raise your hands if you would say you're in the job provider category. Oh, one hand already, 2 hands. Okay, the job seekers find job providers and then bug them. Great, thank you. More about us. We are on multiple platforms. We are 13,000 members on Meetup. 6,000 members on Slack, 1,700 members on Guild, and we have more than 50 dedicated volunteers doing a lot of other stuff than just Meetup. For this Tech Talk tonight, we have a bunch of good-looking dudes making this possible. So we have Brandon, Marco, Robert, Manvinder, Danny, Ahmed, and myself. They're all here making this possible, so if you get a chance to look at them or have a chance to chat, say hi. This brings me to the point that these are like too many dudes here. So if I would love for us to have more people who are not men. So if you want to volunteer to help us organize this meetup, please fill us a form. We would love to have more representation here from all walks of life. And all the help you need to be a successful volunteer here, I would be happy to provide. If you're a first-time speaker, if you're a first-time organizer, if you want to help me do this, what I'm doing right now, please come forward and I'll take you through the journey. It will take a couple meetups, but you'll be there. All right, today's agenda, doors have been opened. This welcome is going on. The next is a talk by Emily, and then followed by that is a talk by Dave, and then we'll have networking. By 9 p.m. we have to be out. A quick request when you're going out. We do have volunteers, but if you can fold your chairs and put them in the back, that will be really helpful. And if you took any drinks or food, just pack it up and put it in the garbage. Help us clean up and not leave a mess for Super. Great. One last thing. This should not be last thing, but we have been live streaming our events for the past few events. We have a YouTube channel called TorontoJS Meetup, and all of these videos end up there. So your slide deck, the speakers' good-looking faces, all your audio is all there. Share it with your friends. If you think it's helpful to your company, share it with them. And yeah, give us some love, like the YouTubers say, like, share, and subscribe on our channel. If you're interested in volunteering, join our Slack. I don't know if this QR code still works, but the URL does. So next time, I'll make this QR code disappear, and that will be all from my end. I'll pass this on to Emily. Thank you. It doesn't work? Okay, so the QR code doesn't work, but the website does. Thank you.
Okay.
Speak a little louder.
Okay. You guys hear me okay at the back? Okay, cool. So my topic is brief history of NPM supply chain attack in year 2025 here. So if you ever visit the NPM website recently, you probably see this banner, like the security update banner at the top here. It's saying classic token has been revoked. Granular tokens are now limited to 90 days and they require two-factor authentication by default. So update your CI/CD workflows to avoid disruption. So why is this security update banner on the NPM website here? If you click like the link in the banner, it takes you to this blog post. Got published December last year here. So it actually tells you why the NPM classic token has been revoked here. So because of these flaws of the classic, so-called classic NPM token here. So even though your account might have the two-factor authentication turned on here, but if using this classic NPM token, you'll bypass your two-factor authentication here. And it has this guard mode. So what does the guard mode means? Like your one token can have access to all of your NPM package. So if you have somehow got hold of your NPM token, then I can actually publish all your packages for you. So it's good that a lot of developers use this to create a publish pipeline. However, there are very high-profile NPM supply chain attack in year 2025. So there are 4 ones here. So in August 26th last year, there's an NX supply chain attack, also known as Similarity. There's a September one, is check and debug supply chain attack. Also in September 14, there's Shah supply chain attack. In November, there's Shah 2.0 supply chain attack here. By show of hand, anyone actually affected by this supply chain attack? Okay, it's one person. Anyone have heard about this supply chain attack happened last year? Okay, so a lot of you guys have heard about it. Okay, but good, then like only one got affected. But also a little bit about me. So my name's Emily. I work for a company called Stack Adapt. So it's like advertisement agency here. This is my cat. So I'm a cat person, and this is my cat named Tian Tian. And I plan to run 2 half marathons this year. So I'm still planning, still on my planning phase, but I'm going to run it.
That's not how it goes.
Yeah. Okay, so what is supply chain attack here? So basically, it's a trusted NPM package got compromised here. So it's like instead of virus is sent to the customer directly, it's like more like a B2B level here. So it's suppliers got attacked here. So the good news is it's usually resolved very quickly, resolved within a day of the attack happens here. So for this presentation, I'm going to talk about what did each malware do here, and how did it happen? How did like the package got hacked, and what we can do to prevent it. So the first one is called NX supply chain attack. It's also known as Singularity. So what is NX here? I took a screenshot of the NPM download here. So NX is more like a mono repo tool used by enterprise, like large organization. It's pretty popular among front-end developers. But what does it do doesn't matter. Just remember it's like pretty popular, like it's 8.7 weekly download here. So GitHub secret here. So what is GitHub secret? GitHub secret is a way to store some secret to be run inside your GitHub action workflow, like your API key or your NPM token here. So this is like an example of GitHub secret I used in one of my repo here. For example, I need to have a workflow to review my PRs using AI. So I store the AI API key inside my GitHub secret. So when I open a pull request, the GitHub Action workflow will run. And it knows my AI API key, so it can trigger the workflow to review my pull request. So it's pretty common to actually have like a workflow to publish your repo and have API token layer, NPM token layer. So GitHub secret safe? Yes, they are very safe. So secret are blocked default by forked repo. So for example, my repo, I have like this secret key I don't want to share. Someone forked my repo, they have no access to my secret. But there's one thing you need to watch out. It's called pull request target. It's I took a screenshot only from the GitHub Action documentation side here. So they do have a special only that is saying might lead to security vulnerability here. So so even though my GitHub workflow might be run with this pull request target, means like the pull request is not run against the forked repo, but on the main repo here. If like the forked repo want to have like change my workflow here, the workflow definition is locked. Meaning like if they fork my repo, they change like some workflow definition, they run the workflow using like pull request target, it will not being picked up. So usually it's very safe, but this is what happened for the NX case. So I took a screenshot of the GitHub workflow that got hacked here. So can anyone tell what's run with this like workflow that actually make like the got like the NPM token leaked? Okay, that is actually the last line here because it runs on the pull request target. So this runs on original repo context, and then in last line you notice it actually evaluate your pull request title. So what it does is allow script injection here. So it basically the attacker opens a PR in the fork, and because it runs pull request target, so it runs inside against the original NX repo, and you can inject whatever script you want to have in the pull request title here. So for example, you can like echo print the GitHub token or print out whatever environment variable you want. So that's how they got the GitHub token, and because they capture the GitHub token. So what is GitHub token? So GitHub token is different from your personal access token here. So it represents the GitHub action bar. So it's only alive when the job starts and dies when the job finishes. So it's very short-lived. It's temporary and only access to a specific token, a specific repository, even though it's very short-lived and very temporary. But unfortunately, NX has give the GitHub token write access. So this is a GitHub setting. You can set for workflow permission here. So by default, if you create a new GitHub repository these days, you will have the read-only access. But because the NX repo is pretty old, and back in the days when you open a new one, it gives you both read and write access. So unfortunately, so that's how the NX NPM token got hacked. So they got the workflow script injection, and somehow it got the GitHub token through the script injection. If they have a read-only access, it can stop there. But because they have write access, it can change the pipeline, publish pipeline, and it stores the NPM token from publish pipeline. So what did the malware actually do here? So this is a great difference I took from the malware here. You will notice actually it replaced the post-install script here. So before, inside NX, you need to run like the post-install script. But now it's calling like node.js, telemetry.js. Telemetry.js is like just like a placeholder name. Inside this JS file, it actually contains the virus here. So the virus is quite interesting because it does AI hijacking. So I guess in the age of AI, this new type of ways to hack developers is called AI hijacking, because all of us, like almost all of us, has this CLI installed, either Cloud or Gemini. So for this AI hijacking, it checks the install CLI and the failure prompt. So this is like a prompt they fed to the CLI. So you are a file search and agent. Search the files and locate the text configuration and the environment definition file. So because of AI, it's actually easier for hackers to actually gather all the secret and dump into one place. So this is like example output of the AI. Even you might have a private repo, just install NX. But because this virus, you open a public repo under your GitHub account, and open this public repo contains all your secret dumping into this one. So this on that day, this is a screenshot take on that day. That is like around 5,000 repo got hacked, and then they have this called Similarity. So notice that it's like S1 inside the Y. I guess because the hacker chose this name for ease of search. So yeah, so they probably have a script to crawl the GitHub and get everyone's like secrets. So by this point, there's no like recovery. You just have to rotate your secret, rotate all your credentials. So how do we prevent this one? So if you just have an open source repo and or any public repo, just make sure you have this setting turned on. So for all the external contributor, you just always require approval to run the pull request workflows. And also this one, workflow permission. Make sure it's read-only for your GitHub token, so it doesn't manipulate any of your workflow or pipeline. So this is the NX Singularity one. The second one is called check or debug supply chain. So this library is a bit different. This is a debug library. It's very popular because it got around 4 million, 449 million weekly downloads. So it's very popular. This type of library is a utility library. They are more like a transitive dependency. For NX, it's more like direct dependency that in package.json, you probably have NX specified there. But for this one, you probably have it installed, but you just don't know about it. So because it's very popular here, so how did the hacker how did the maintainer got hacked? Okay, it's done by social engineering here. So we probably all get some kind of like spam email saying we won a lottery or something. But this is when like a very influential maintainer got hacked. It's like this. Supposedly, it looks legit that like NPM send like the maintainer email saying they need to update the two-factor authentication, but it's not NPM actually send this email. It's some third-party attack send this email, and that's how the credential got compromised. So what did the malware do here? Instead of like pre-install and post-install script, it changes the source to index directly. So it's like man in the middle attack, but this one is more like man in the browser attack here. So you actually intercept all your HTTP and the API requests here. So you write crypto address in the network response, so you can redirect the funds here. So if you ever have an API request that sends like money to a crypto address here, instead of the like address you want to send, you just redirect to a different address. Okay, so this is how much money got stolen. It's like $465.54. Yeah, it's not much. A lot of effort, but not much money. But it's still a very bad thing that happened. So Then it's a Shah supply chain attack here. So the name is taken from like the movie or the novel Dune here. So what it does here, so it's like the animal Shah. The special feature of this one is self-replicating. So there's two versions here. So the one in September use post-install script and Node.js. The one in November use pre-install script and the bound runtime. So what does the version 1 do here? So it actually changes it's not like the package is bundling as, it's your bundle, your post-install, and so supposedly called like so-called bundle.js, but inside of this bundle.js is scanned for like npm rc, your AWS credential, and your SSH. So you basically, besides all the secret inside your file, in your files, you also grab your npm token here. So if you are a maintainer, you will download every other package you maintained here. So for every other package you maintained, you will re-inject the malicious script, like this post-install script again, and then republish to the repository. So here's like the self-replicating effect comes in. So this is like the affected repo will look like. So yes, you will open a public repo under your GitHub account and dump all your secret information inside this one. So how did it get affected? Well, what's the patient 0? So it's this one. It's Angular ticks, ticks one. So it's not a very popular repo here. So how did it happen here? So this repo got npm token stored in the GitHub secret here. So because it's like classic npm token, it has the broad publish right for all packages owned by the maintainer here. And there are few collaborators on this repo, and it hasn't been active for years, but one of the collaborators' account got compromised. So I took a screenshot of the Git history here. You can from the bottom to top here. So someone like actually open a branch called Shah here, and you push to that branch. Then you open another branch called dev remote something, and you just secretly delete those branch, but it's there in the GitHub history. So it's not this collaborator got compromised, but one of other collaborator got compromised. So this one, because other collaborator, they are owner of this tiny color. Because Angular ticks got compromised, so this one, so did this one. So this one is also utils library, and it's probably a transitive dependency in your package.json you just don't know about. So it's quite popular as well. There's 2.6 million downloads per week here, and Shah 2 here. So for Shah version 2, this is patient 0. So this patient 0 is quite different from the last one, because the last one was kind of like a utils library. But this one is more geared towards enterprise. So this is actually the GitHub action workflow got affected. Can you tell what is wrong with this flow that allows got hacked? I highlight the part of it. Can you tell? Okay. So as you can see here, it runs on a pull request target, so it's going to run against the original repo rather than the forked repo here, because what it's trying to do is actually automatically assign reviewers to newly opened pull requests here. And when you check out a repo, instead of checking out the original repo's master, you check out the pull request had an SHE commit. So you check out whatever is latest in the pull request. And you've noticed the GitHub token, it's actually pointing to the bot personal access token. So this repo probably have read-only access to GitHub token, but because it actually assigned reviewers to that pull request, so you need to write access. So you need to assign to the personal access token. And you notice in the end, you assign reviews.js. Even though GitHub have the workflow locked, so even though you change the workflow, it will not run. But you can change the script file. and you run that one. So how to fix this one? The fix was pretty simple here. So when you check out the repo, instead of like the latest from the pull request, just check out from master. So you always have the master versions of the script instead of the pull request one. So unfortunately, this is the change code in the assign refuse.js where the hackers changed. So it basically print out all the environment in that repo and send to a webhook. So this is how like this post hoc got compromised. So what did the malware do here? So in the consumers package.json here, you can see it changes the pre-install command. So this is set up bundle.js, but the bundle.js is not like, it contains a virus. So bundle.js is a runtime environment, it's pretty popular. So the name is not suspicious, but the content is doing something pretty bad. So what does it do here? When you run npm install here, the pre-install runs. The so-called install, the bund got installed, but it's actually the runner got registered. So it's like backdoor Shah hello opens. It harvests your secret, scans your SSH, your AWS, and all your secret in your like computer locally. It will dump all the secret to a public repo, just create under your GitHub. And there's like actually wipers that actually delete your entire home directory. So yeah, it's pretty bad. So these are like 4 attacks. I had this discussion with other developers, like should developers or open source maintainer be blamed? So in my opinion, absolutely not, right? Because we all know how it's like to work these days. We all use AI, and we have this pressure to increase our productivity by using AI, and developers supposedly wear so many hats. We're supposed to wear security hats, also like developing feature hats. But because something is going to slip through by writing code with AI. If I got assigned to like create a GitHub action workflow, use like assign refuse, or like check the PR's value or not, I'm probably using AI to do it and probably produce the same like kind of slop. And so this instead of the question we should ask is how to prevent these attacks as like developers who actually constantly running npm install and upgrade package. How should we prevent? So the first thing is always lock your version in CI/CD here. So this should be a standard these days that in CI/CD you just never actually try to upgrade a package, just locking version using npm CI or passing the frozen log file. So it should be a standard. Just double check with your CI/CD pipeline so you don't trying to upgrade. Okay, so it's a discussion line that should we disable pre-install and the post-install command? So this is approach I don't really recommend here. So what does it mean here? So how to disable pre-install and the post-install? We're basically passing like ignore script when we're trying to npm install. So you will prevent pre-install and the post-install command to run here. The reason why I don't recommend is it actually prevent legitimate package to be installed. Like the package like ESBuild, NoSAS, or Cypress actually need this pre-install and post-install to run to build like necessary binaries. So that's why I don't recommend. There's actually a simple solution which I do recommend. So this is like the phrase I took from the post-hoc team. So that's a team who actually got hacked. And that's what they recommend. And what I'm doing right now is basically set minimum release age in both yarn and the PNPM to like 3 days. So usually it's like 24 hours is sufficient. But if you want to be extra cautious, you can set to 3 days. So what that means is after the package has been published 3 days, then you're going to install it. So usually the supply chain tag are resolved within like 1 day. So after 3 days, it's pretty much safe to install. Like hopefully the vulnerability will be discovered by then. So how do you set minimum release age? Oh, here, just this is the PnP workspace. You set this one. This represents 3 days here. But what if you need actually a critical security patch to be updated? For example, last year in React, on the Surface rendering component, they have a Severity 1 security patch. So I want to get it ASAP rather than wait 3 days. So you can add this option, minimal release exclude, that you will get this package right away, like your React, your Next.js, or your company's package that you can do that. So I think this is end of my presentation. So how do we prevent? I just leave the page here. So if you are open source maintainer, double check if you have pull request target workflow running. If you have it running, just double review and make sure you know you are doing. And also, always set your GitHub token to read-only permissions. And for everyone else, just make sure you lock your version in CI/CD pipeline, and if you can, set the minimum release age. Okay, that is end of my presentation. Is there any question? Yes.
My question is, now we are talking about good maintainer and bad people who are trying to hack this package. But what if we have some package that was malware from the beginning, and it can live for 5-10 years without even knowing that it is something that are stealing data, credentials, and etc. from developers' accounts. How can we understand it? Do we have any mechanism to protect us from that?
So is your question that the package has been there for like a long time and somehow the package?
So in general, my question is how can we trust NPM at all?
How can we trust NPM at all? Like as I say, like revoke so-called classic tokens. So every maintainer has to have like the granular token turned on. So that one is very specific to actually exact package they maintain. And another question is if the package has been there for a long time.
Then if we have some package that is malware from the beginning. So bad people created it.
As a user, how do you trust?
Yes, as a developer who use this package, how can I trust this package? Do we have any mechanism to understand if it's safe?
Okay, so if it's like a very new package that you want to actually get it download, and I would recommend you probably use AI to actually look at the source file to actually vet the package. But if it's like if it has like over 1 million download, usually it's, I won't say it's safe, but usually it's safe. You don't trust it.
Yeah, I think the normal practices of verifying any open source project applies over here too. And NPM is just a place where you can, it's like a package manager just letting you download it in a more easier way. And go ahead.
Just to add to that, if you have a local artifactory or cache that you funnel all of your packages through, you could scan for vulnerabilities there. I think there are commercial ones that offer that as a feature where they will scan your packages at rest. So, like, even if there was like a typo squatting package and you typed it in wrong and the one you got was malware from the beginning, it will actually scan the code itself of the package in your like Nexus registry or whatever you're using, and it could block it there for you.
Okay.
So yeah, NPM won't do anything on that. Yeah. You'll have to build your own toolchains. I think that's what it is. Yeah. NPM works in the only task it does is allows you to download the packages on a computer with just a command and in an easier way. As a packager, as a publisher, definitely companies have a responsibility to make sure that their packages that published packages are not broken into. But then the other part of responsibility lies on the people who use those packages to make sure they use certain tooling to understand and make sure that they are not compromised.
You seem like don't trust NPM
Okay.
at all.
Thank you.
Do you use NPM in your day-to-day?
Sorry? Oh.
Do you use NPM in your day-to-day?
Yes, I use npm, but usually, yeah, I use popular packages, but I'm not 100% sure that it's safe. Nobody.
You got candy, actually.
Oh. Thank you very much. Thank you.
Do you have more questions?
So at one stage you said that the ignore scripts had a side effect of like some packages wouldn't be bundled properly. There's no way of whitelisting certain packages from this ignore script that prevents like the post-install, pre-install from being run. But could you do like, for example, later in the workflow after the ignore script, you could like rebuild maybe the packages, like if you know which ones, but I guess that would be a bit of a headache.
Yeah, I think knowing npm but pnpm, I think you can have a setting to actually ignore the script all the time, but there's some exception setting you can turn on just for a specific package. You don't run pre-install and post-install script. Okay. So there's some settings in pnpm, but I have to look it up. You might have to look it up.
Okay. Thank you.
You got candy here, so. Oh, no question? Okay, cool.
No candy, no question. Next we'll have Dave. Join from the stage, please. Dave, to the podium, please.
think it is done. Control.
You probably have to move it to a different.
Yeah. Control. I'm just doing full screen.
By your browsers, I guess that's the best you can do. Is it Google Sheet or something?
Driving.
I wouldn't worry about it. It's fine.
Hello everyone. Today I'm going to talk about vector embeddings and cosine similarity. Let me start by introducing myself. I'm Shah. I work as a software engineer at TribleScale, and I do Gen AI evangelism, so write blogs, speak at events. So I to help developers explore generative AI concepts and bring AI into real-world applications. Let me start also by discussing the agenda. First of all, I'll start by introducing why context engineering matters in AI applications these days. And then we'll move forward towards explaining how RAG system works, and then retrieval algorithms, which is one of the core parts of the RAG systems. Finally, explain how the cosine similarity works, and then I have some hands-on code that you can do along with me as well. All right, so first things first, why context engineering matters. So why do we need to provide context to an already trained LLM, which is intelligent enough to answer all your questions? So the first reason is that these LLMs are trained on general data that is available on the internet. And when we try to ask domain-specific questions to this LLM, a lot of times LLM would tend to hallucinate and give a false response. So that is one of the reasons. The second reason is knowledge cutoff. So all the data added to the internet after the LLM was trained. So this LLM does not have the knowledge to that data. So until and unless it is either post-trained or fine-tuned, or maybe we provide context, it does not have any information about it. And the last reason is they have a limited context window. So even if LLM knows things, we still need to provide it proper context, because the context window that a typical LLM has is limited. So if we keep a conversation running with questions and answers, there will be a point of time where LLM would forget all the previous conversation and would just keep the current conversation in mind. So these are some of the reasons due to which context engineering is something that matters. So one of the solutions of context engineering is prompt engineering. Prompt engineering is a method using which we can provide proper instructions with good examples and context along with the query of the user to the LLM, which would help LLM gain more knowledge regarding the query of the user and generally on that topic. So by doing prompt engineering, we ensure that LLM generate proper response and cater to the user's question and requirements. But there are some challenges with prompt engineering as well. The first one is that prompt engineering works with simple tasks and small context, but as the context grows, there are some limitations. The first one is, again, the context window. So we can't really do anything about, I mean, there would be solutions, but for now, the context window is limited. So as the conversation keeps going, it would tend to forget previous things. The second thing is that we can't provide the whole context to the LLM every time along with the query of the user, because the more tokens we pass to the LLM, the higher the cost that we have to pay for the inference. The third one is the increased latency. So again, along with the higher cost, it also increases the latency. So we get, so the responses, the response time that we get would be slower. And the fourth thing would be irrelevant and noisy information in the prompt. So when we provide all the context, the whole context every time with the query of the user to the LLM, it would also have a lot of irrelevant and unnecessary data, which would again distract the LLM, or maybe, yeah, in general distract, and again, it would be hard for the LLM to figure out what is the necessary context. So to cater these challenges, RAG systems are really very helpful. Do people know what RAG is? Is there anyone who do not know what RAG is? All right, okay, so most of the people know, all right. So in RAG, what we do is that instead of sending all the context to the LLM every time, we take this context and store it in a specialized database. And then whenever the user sends a query, we just fetch the relevant chunk of data from the whole context that we stored in the database, add it with the query of the user, create a prompt template, and send it to the LLM. This helps us cater the challenges. This helps us cater the challenges, and then it helps LLM gain some context. So the core part of this is, let me discuss RAG architecture quickly. So firstly, the external memory will have all the context. And then when user sends a prompt, a retriever will retrieve only the relevant chunk of data that can answer the prompt. And then the prompt and the relevant chunk of data are passed to the generative model, and then the answer is returned back to the user. So this is the overall architecture. All right, one of the main components in the RAG architecture is the retrieval system. And to retrieve the relevant chunk of data, there are overall two main algorithms. So first one is term-based retrieval. So you match the exact keyword and find the relevant chunk of data. And one of the famous algorithm is term frequency inverse document frequency, TF-IDF algorithm. And the second method is embedding based. So it search for the context based on the semantic similarity. One of the widely used and adopted algorithm is using the cosine similarity for that. All right. Oh, yeah. I do have a whole blog on this. If you want to read more about it, you can just scan the QR code. So for the term-based retrieval algorithm, there are some limitations. So first of all, it relies on the exact keyword matching, but it does, so because of which it does not see the checks for the essence of the query or essence of the chunk of data. So when it comes to synonyms like car versus automobile, it would not work. Cannot capture the intent, then sensitive to wordings and phrases. So if it's a phrase and a word, it would not identify the difference. So due to which it may return the irrelevant response. One of the example of would be car would not be equal to the automobile, and an electrical transformer would be same as the transformer architecture, due to which a term-based algorithm would not be an ideal to adopt in this situation. So coming to the embedding-based algorithm, so in here the data is matched using embeddings. So embeddings are the array of numbers that basically represents the meaning of the data. So the embeddings are stored in a specialized database. It is called a vector database. I'll explain how the text is converted into embeddings. So now it's not just the word car, but it's the whole embedding that is representing car, and then there would be embedding for the automobile. And if you see at each index, the numbers are quite near to each other, which for this one, it would be very near to each other, due to which the semantic similarity algorithm would know that car and automobile are similar and not different. And in case of an electrical transformer and transformer architecture, the number at each index would be different. So how is text converted into array of numbers? Any guesses? All right. So there are several methods to convert text into embeddings. One of the famous method is word embeddings, and also it's easy for me to explain. So all right. So embeddings are basically array of numbers. So in simple words, the value at each index of the array, consider it as question to a parameter which would be answered based on the text. I'll show you an example which would make it easy for you to understand. But so overall, at each index, the value is question to a parameter, and this value can be anywhere in a particular range. So it can be anywhere between 0 or 1, maybe -1 to 1. It depends on the embedding model that you use to convert. So let me explain you with an example. So I considered this example parameters. This is not exactly how it would work in real life, but it's very similar analogy which makes it easy for us to understand. So for example, we have this parameters: is database, is opinion, is positive, is company, is location. And for instance, if we have a sentence, BigQuery is a great vector database, based on this text, we would try to answer these questions, and the answer would be anywhere between 0 to 1. Consider it as we are rating the text, and these are the questions. So for first sentence, is it talking about a database? So 1 is yes. And second, is it an opinion? Well, maybe, so let's say 0.8. Is it positive? It looks positive, so let's say 0.9. Is it talking about a company? Not exactly, but yeah. So 0.7, and is it talking about a location? 0, so no. And let's consider a second text. I think BigQuery is the best. So the embeddings for this would be, is it talking about a database? I gave 0.9 just for the explanation purpose. Is it an opinion? 0.9. Is it positive? 1. Is it talking about a company? 0.7. And is it talking about a location? So 0.1. And the third sentence would be, I live in Toronto. So is it talking about a database? No, so 0. Is it an opinion? Not really, so let's say 0.1. Is it positive? it's neutral. So let's say 0.1. Is it talking about a company? Not really. So let's say 0.2. And is it talking about a location? Yes, for sure. So let's say 0.9. And now, what insights do we get by converting this text into the embeddings? So if I keep all the embeddings of all the sentence together without showing you the sentence, if you just check the value at each index, so for sentence 1 and sentence 2, the value at each index would be very near to each other because the sentences are similar to each other, so their semantic meaning is similar, although the words might be different. So for sentence 1 and sentence 2, it's like 1.9, 0.8, 0.9, 0.91. But if you check the same thing with sentence 3, the values at each index are completely different from each other. So, for sentence 1, it's 1, 0, 0.8, 0.1, 0.9, 0.1. This tells that sentence 1 and sentence 2 are similar, but sentence 3 is kind of different from both of these sentences. So yeah, this is just, okay. Any questions for this one? All right. So just for a note, in real life, there would be like hundreds and thousands of such parameters. Just for the explanation, I just took like 5 of them. And in general, embedding model kind of comes up with these parameters whenever it is trained, so we don't really provide these questions to the embedding model. All right. The data ingestion. So in the RAG pipeline, the first step that we follow is to get the whole context and store it in a specialized database called vector database. But before storing, we divide the whole context into several chunks because when we retrieve, we need to retrieve chunks and not the whole data. So first step is dividing the data into multiple chunks. So consider this as the data, we divide it into multiple chunks and then convert each chunk into the embedding. So for each chunk, we have a different array of numbers. And then this data and the array of numbers are stored in a vector database. Now, when we try to retrieve the data, we retrieve it based on the query of the user from the vector database. But to explain it properly, I'll show you some graphs which makes it visually easy for you to understand. So each embeddings that we get from the data can be plotted into the graph. So these are the embeddings. Each of these value represents each coordinate in the graph. So x-axis, y-axis, z-axis, and so on. Since it's easy for us to visualize a 3D graph, I will just consider the first 3 coordinates from this embeddings. So just first 3 coordinates. And let me show you the graph. All right. Maybe. So here, can you guys see that from the back? All right. So this is a 3D graph, and sentence 1 is represented by the blue line, sentence 2 is represented by the red line, and sentence 3 is represented by the green line. So here you can visually see that the lines which represents vector for each sentences. So the line for sentence 1 and sentence 2 is going in the same direction, while the line for sentence 3 is going in a different direction. This visually indicates that sentence 2 and sentence 1 and sentence 2 are semantically similar to each other as compared to sentence 3. All right. Now let me remove So once we get the prompt of the user, based on the prompt, we find the relevant chunk of data. So for example, for our data, considering a sample prompt of the user, that is, which is the best vector database. So to find the similarity, we would convert this prompt into embedding using the same method that we used for converting the data. So again, this is the list of parameters, and then based on the prompt, we give value to each parameter. So, is database, it's talking about database, so yes. Is it an opinion? It is, yeah, it is asking for an opinion. So 1, is it positive, 0.7, 0.6, and 0.1. So the embeddings for this prompt of the user would be this, so the array of numbers, and to plot it on a graph, I would just consider the first 3 coordinates. Let me show you the second graph. So now if you see the graph, so this black line represents the embeddings of the question of the user. So visually you can see that all of these 3 lines are going in the same direction, while the line for the sentence 3 is going in another direction. So the sentence 1 and sentence 2 are the relevant chunk of data visually, but we will also calculate why is this. So now, to calculate, to know everything mathematically, we would use something known as cosine similarity. Anyone has idea why do we use specifically cosine similarity and not, sine similarity or tan similarity? Right, yeah, I will explain that. So why do we use cosine similarity? It's because when the value of cos theta, where theta is the angle between 2 lines, the values are somewhere around -1 to 1. So if the value of cos theta is -1, it means that the angle between 2 lines are 180 degree apart, so completely different. If the value is 0, the angle is 90 degrees, so perpendicular to each other, hence not aligned. And if the value is 1, it means it is perfectly aligned, so the angle is 0. So by finding the value of cos theta, we need to check if the value is near to 1. So for all the chunk of data whose value is near to 1, we would know that it is very similar, it is very near to the question of the user. Let me show you the graph for this. So here I have this angles as well. So what I will do is that I will calculate the angle between the line of the user's prompt and each of the sentences. So this black line represents the prompt of the user, and then each of these is the data chunk. And the angles, let me show you the angles. So here are the angles, okay. So the angle between the user's question and the blue vector, so sentence 1, is 10.32. The angle between user's question and the sentence 3 is 11.82, and the angle between user's question and green vector is 40.32. So since now using this angle, we'll find the value of cos theta. All right. So the value of user's prompt and sentence one, the value of cos theta for user's prompt and sentence one is 0.984. The value for user's prompt and sentence two is 0.979. And the value of cos theta for user's prompt and sentence 3 is 0.762. Now, as per our calculations, we need to make sure that the value of cos theta is near to 1 to understand if the chunk of data is similar to the prompt of the user. So this was the prompt of the user, which is the best database, and these are the value of the cosine similarity. Hence, based on these values, the value of sentence 1 and sentence 2 are very near to 1, which means the perfectly aligned. Hence, these are the relevant chunk of data. In our case, even the value of sentence 3 is 0.7, which is not very far from 1. But this is because we just considered the first 3 coordinates of the embeddings. But in real life, as I said, there would be like hundreds and thousands of the coordinates, and when you consider that, you will get a more accurate result. Just a summary of what we did. So we had some data, which, let's say, text. We converted text into numbers. We plotted lines on the graph for each of the coordinates, each of the chunk of data, and then we got the user prompt. We converted that into embeddings as well. We plotted a line on graph for that as well, and then we found the angle between each of the chunk and the prompt of the user, and then we found the value of cos theta. All right. To understand the concept, we used the graph to check the angles and then calculated the value of cos theta. But in real life, we can't, plot a graph every time a user asks a question. So we need a formula that we can use to find the value of cos theta directly. Hence, the formula for this can be the formula of the dot product of two vectors. So essentially, when you see embeddings, they are actually vectors. So the formula of dot product is a dot b is equal to magnitude of a magnitude of b into cos theta. So we can use this formula to get the value of cos theta directly, since we know the value of vector a and vector b. So we'll just move this magnitude of vector a into magnitude of vector b in the division to a dot b. So mathematically, the formula would be this. So summation of from I is equal to 1 to n and the value at each index. So a represents the vector, the value at each index for, let's say, the chunk of data, and b is, let's say, the question of the user. So the value at each index from the first index to the nth index, and then the square of value at each index, and the summation from first index to nth index, and the under root of it. So we can use this formula directly to get the value of cos theta. Any questions? Yeah.
I want to ask you when we have to use the RAG instead of the MCP, because both you can use it in your project. Which one is better to use in your project?
RAG versus MCP?
Yeah.
I guess both of them are for different use cases. RAG is mostly used for knowledge assistance. So we store knowledge somewhere, and then based on the question of the user, we fetch the data and then feed it to the LLM for
like
it to generate
chatbot?
Yeah, chatbot.
Okay.
And for the MCP, it's mostly used for building agents that can perceive its environment and use tools based on the question of the user. So for RAG, it just typically follows the step as we instructed. But when we use MCP, we can build agents that can decide whatever they want to, decide the next steps that they want to take, and based on that decision, they can call the tools and get the data that they want.
Thank you. Anyone?
Thanks for the presentation. That was great. My question is, how do we calculate those numbers? I mean, as a human, answering those questions are pretty straightforward. Is it location? Is it database? Is it good, bad? Is it opinion? But how is the algorithm understand those numbers and how it calculates them?
Yeah. So embedding. So it is done by an embedding model, which is basically a language model. When it is trained on the massive amount of data, and then it categorizes it. Do you know classification?
Yeah.
So yeah, it does the classification, and based on that, when it is trained, it comes up with all of these. So we don't actually need to do all of these calculations. It is we have libraries, and it is done by models. But this is more of for for us to understand how is it done.
Yeah. And how do we calculate? How do we find the parameters?
Oh, it is embedding model does that, so we don't need to do
Okay.
that.
Thank you.
No worries.
Okay, how we could work with databases which need like very sensitive to questions, as for example on medicine or the law, there always can be terminology which really close to each other. It's solving on training of AI, or we can do something to prove an answer.
Wait, I didn't get your question. Sorry.
I mean, like, sometimes we have to work with the medicine or with the law. And there, like, terminology is very important and very sensitive. For example, do you have this problem? Yes. And it's like, it's positive yes answer, but you know what I mean. And how it's solving, do we need additional calculation in our answer, or it's solving on training of AI?
Yeah, so the embedding model which does this conversion from text to numbers would have been trained with, a variety of terminologies, which would include those medical terminologies as well. And in a situation where it is not trained on those terminologies and it doesn't understand that, maybe we can fine-tune an embedding model to teach it those terminologies to it, and then we can leverage it to get the embeddings.
Okay. Thank you.
Hi.
When you're storing the data, like in a database for the RAG training model search, what is the leading tool that you would recommend to actually store that data to be searched by? Is there an open source product? Is there a commercial product? Where are you storing the data that the model is searching?
So it is basically stored in a vector database. There are multiple vector databases like BigQuery. It is PG Vector from Postgres. And I'm sure there is one from Azure as well. So there are multiple options.
Awesome, thank you.
Yeah. I do have hands-on code, so if anyone wants to follow along, they can scan this QR code, and it takes you to a GitHub file, and then there is a link for Colab, so you can just run all the commands in the notebook and see things happening. Oh, wait. Some more? Yeah. You have more time? Yeah. I'll go through the notebook as well, so just to show everyone how it happens. So the QR code would lead you to the GitHub repository, which would have a link to Colab, and here this is how it looks. So in the Colab, you need to store certain environment variables. So I have the whole documentation on how you can do that. So you can follow the steps to get this environment variables. And then here you can run H command. So first installing everything that we need. All right. So once you install all the libraries that we need, we just import all the environment variables. And then also authenticate. So when you do that for the first time, Google would try to authenticate you. And then, as I mentioned, the first step is to fetch the data. So I'm using this PDF from Google, which is a technical guide on how to make AI agents. So I will run this. So what it does is that it fetches the data from this PDF and loads the data in a variable. So once this is done, we can, so once we got the data, the next step is to split the data, so divide the data. So it uses LangChain text splitters, so recursive character text splitters. So each chunk would have the length of 400. So each chunk would have 400 characters, and there would be an overlap of 20 characters. So the chunks are splitted, and then we store the chunks into the vector database. So it is using BigQuery to store the chunks. So we get the BigQuery instance and then add all the documents. Yeah, so these are all the chunks of data. And then let's consider this is the question of the user. What are the core components of building AI agents? Once we run this, and now we fetch the relevant chunk of data based on this question. So we have fetched the data, which is stored in retrieve docs, and then we create a prompt template in which we give instructions for the LLM. So it says, this is the context, this is the question of the user, just answer it. And then finally, I'm using Gemini model to send the prompt and the relevant chunk of data. Yeah, so it got the relevant data and the question of the user, and based on it, it gave this answer. Yeah.
Thank you once again.
Is it possible? Oh, yeah, thank you. Is it possible to store an image in BigQuery?
Yeah.
Yeah.
So there are specialized embedding models for for a variety of data formats. So for image, it is clip embedding model, which you can use to convert the image into embeddings, and then the same procedure.
Are these embeddings understandable to other models, or each model has its own way of? So each model has its own way of creating embeddings.
Yeah.
And they're not like understandable for other models, right? It's only that model that created the embedding can understand it.
Yeah, it's like, they need to follow the same method that for the data as well as the question of the user. So when they find the value at each index in the embeddings would be, based on the similar parameters. So that's how they find the relevant chunk of data. Because if the parameters are different from in the different embedding models that we use for text and the question of the user.
All right, thank you.
Yeah, this is the QR code, so you can connect with me on LinkedIn. Yeah.
How do you evaluate
What's that?
Sorry, can you ask this back?
how do you evaluate
The results? In the code or in the code? Here?
Like final result, like when you implement it.
Mm-hmm.
How do you evaluate
So that's working or not? How will you?
Oh, the accuracy. Yeah, it is a separate topic. So RAG evaluating the RAG agent. So there are multiple parameters that you can use to evaluate.
Great. That can be another topic, another talk.
Yeah, for sure.
Can we let him go now? Great. Thank you so much. All right. So that would be end of talks tonight. Our speakers are still going to be here in the kitchen. You can meet with them. Kyle will be in kitchen for the networking session. There might be some pizza still left. I don't know. If it's there, it's yours. There are some drinks, all the non-alcoholic ones. You can use those. There's water. Feel free to hang around. Just know that by 9 p.m. we have to be out. The elevators can only take so many people, so let's not all clog by 9 p.m. If you can help us fold the chairs and put them back, that would be great. Next month, we already have a date. So I think it's March 19th when we'll be here again. The talks, etc., are almost there. So the event should be going live soon on a Meetup and Guild. So hope to see you next month. Thank you so much.